on section 3 is parent functions. So parent functions and piecewise. Okay, but essential question number 1, or goal objective number 1, is can I identify parent functions and describe/identify characteristics? So we just want to get really confident and comfortable with a variety of parent functions, and then we're going to grow on that as we learn about more functions. So can I identify parent functions and describe/identify characteristics? So it's when we're identifying and describing characteristics, it's gonna bring up a bit of section 2 in looking at those graphs and also analyzing. So analyzing the function and analyzing the graphs. So our first parent function is our simplest. It's our constant function. So if we have f of x equals some constant, so some value, some number, and that constant.
Okay, 11th graders, last name beginning with C. Please head down to the new
Sorry for
auditorium
the
entrance.
announcement.
11th grade, last names beginning with C.
So we want to be comfortable with if we're equal to a constant, what that graph is going to look like, what kind of behavior that graph is going to have. So how would you describe if we knew f of x is equal to any number? How would you describe that? A straight horizontal line. Yep. So straight horizontal line at wherever that value c is, right? If that was a 2, if that was a 5, a negative value. Yep, exactly. Okay, the characteristics that we're going to be identifying about all of our parent functions is domain, range, intercept, we're going to talk about symmetry, continuity, end behavior, and increasing or decreasing. So a couple different pieces. If we think about domain, that's a review from section 1 and section 2 already. What x values would a constant horizontal line cover? How would you guys describe that domain?
Would it be negative infinity to infinity?
Negative infinity to infinity, yep. Thank you. And then range is that one y value, right? Whatever y value it is, because it's that same y value the whole time. So then we would just say, you could say that c value to that c value. In a way, it'd be better if we used our set builder notation and just say y is equal to c. Okay, so domain, range, and we want to be able to talk about intercepts. So if we're thinking about x-intercept, if it's a horizontal line, will it ever hit the x-axis? What would you say?
No.
No, unless it's y equals 0 or f of x equals 0, right? So none unless y equals 0, which that would be that it hits the x-axis the whole time. But normally, that's the exception to the rule. Okay, and then y-intercept is a reminder. Intercept is points, right? So y-intercept x equals 0, and y is going to be whatever value or whatever constant we have. Okay. So then symmetry. Symmetry is if you were to reflect it, would it be the same across the x-axis, y-axis, or the origin? So does this parent function have any symmetry to it? If you reflected it across the y-axis, would we say it would be the same graph? What would you guys say?
Yes.
Yes. So symmetric about y-axis. So you could reflect it across the y-axis. It is not symmetric about the origin. To be symmetric about the origin, then we would be able to take a point and rotate it 180 degrees and land back on that graph. And this would not do that. Okay. So, and then continuity. So continuity is a question. Is it continuous? For us right now, the definition of continuous or the idea of continuous is if we were able to start at any point on the graph and continue drawing the whole graph without picking up our pencil. So the answer would be yes or no. What would you guys think?
Yes.
Yes. And it is for all domain values. If you're asked what values x is continuous for, then we could say for the whole domain. Okay, and end behavior is a new, so continuity is a newer topic, and symmetry, you see symmetry more in geometry, so it might be a little bit more of a review now coming back for us. So I do want to note that symmetry is either going to be y-axis or origin. Okay, and then continuity, you see it in algebra, you should talk about it in algebra too, but we are going to cover it more now and then especially in calculus. It's a definition that we use limits with. So then end behavior is introduced in algebra 2. End behavior is what is the behavior of the graph as you go to those arrows, the ending arrows. So where is the graph going towards? The way we answer that is we say as x goes to negative infinity, f of x goes to blank. And as x goes to infinity, f of x goes to blank. Okay, so looking at our graph here, as x goes to negative infinity, where does our graph go to? So where would you say the y value? Remember, f of x represents y, the y values. So where would you say the values go to? It might be a simple question, so making it feel tricky, but it's not. What do you think? It doesn't go anywhere different because it just goes to the answer of C. So y goes towards the, so what we want to say is what answer is it going towards? It doesn't go anywhere different because it's constant the whole time, right? So it's going to go towards whatever C value it's at. And that's going to be the same for our, as x goes to infinity. Where does this arrow goes towards? It goes towards the y value of C. That's where it was kind of a simpler question that might make it feel tricky, but it's not intended to be. So the last characteristic we want to be able to describe about every parent function is increasing or decreasing. And we want to be able to identify what x values, when we say, yes, it's increasing, we want to say what x values it's increasing for. Yes, it's decreasing, what x values is it increasing for. In this case, because it is constant, Is it either increasing or decreasing or neither? What would you guys say here? It is neither. It is our most basic function, so sometimes the answers, yes, are the simplest. So neither. So then going to our second. So in a way, our function number 2 is where you guys start learning about functions. It is our linear parent function. And the parent function notation, to be a parent function, it is the function in the simplest form. So a linear function, simplest form is just x, right? So that graph, when graphing it, you would think about linear is the line, so graphing a line, right? Slope and y-intercept. Y-intercept is 0, slope is 1. So it's going to be at the origin.
Okay, 12th graders, last name beginning with C. Head down to the auditorium for your pictures. 12th grade, last name beginning with
Sorry
C.
for the intercom. And then that diagonal, right? Slope of 1. So you can put the 1 plus 0. Okay, so we're going to answer all the same questions. As we're answering them, we're getting that practice of analyzing the function and the graph. Domain. So if we think about a line, its domain is what x values does that line cover? What would you guys say?
Negative infinity to infinity.
Again, negative infinity to infinity. So that's going to be a lot of our starting functions, but we're going to get some cases. And we saw those in sections 1 and sections 2, where that's not always the case. So negative infinity to infinity, our range last time was just the value c, right? But now our diagonal is going down and up. So our y values are also, would you feel comfortable with negative infinity to infinity? Or if you're putting in set builder, it would be all reals. Okay. Feeling good so far? They're the simpler functions. Should hopefully be pretty quick. So then intercepts, right? They're the points where we hit the x and y axis. Parent functions, most commonly the x and y intercept is the origin. Okay. So then again, our newer questions. So these are questions that we have done a lot in pre-cal or in algebra 2 and algebra 1. So then the newer questions are symmetry. So is it symmetric about the y-axis or is it symmetric about the origin? So that question would be, if we reflected over the y-axis, will we get the same graph? Or if we take a point and we rotate it 180 degrees, will we land on the graph again? And that's for every point on the graph. What would you say? Symmetric about the origin. Yep. So in this case, it's nicer to see because it's the 180 is on that line the whole time, right? So symmetric about the origin. Okay, and then continuity again is a yes, because if we picked a point on the line, we would not have to pick up our pencil as we're driving it, or not driving, as we are drawing that line the whole time, right? So continuity is yes. It is continuous for all. Yes. For all domain values. Okay. And then end behavior. So as x goes to negative infinity, where does our function, keep in mind that's our y value, where does that go towards? So if we're looking at that arrow on the end, what does that arrow tell us that we're going towards? What would you say here? Our y values, yep, go towards negative infinity. And that's going to be the same idea as x goes to infinity. That other arrow tells us that our y values go towards positive infinity. Okay. And last, increasing or decreasing. What would we say for this graph? So last time it was neither because it was constant horizontal. What can we say here? Would you describe this graph as increasing or would you describe this graph as decreasing? Keeping in mind, we read a graph from left to right. Increasing, yep. So, and in this graph, so it is increasing, starting on the left, going to the right, and it is increasing the whole time, right? So we would say our answer here would be increasing for the set of x such that x is an element of all reals, negative infinity to infinity. So it's increasing the whole time. Okay, but not every function does that. And if we think about quadratics, right? We know quadratics make that U shape, and that's actually where we go to next. So number 3. All right, 1, 2, yep. 3 is quadratic. So our third parent functions. So f of x, the parent function is just x squared. So the parent function is always the simplest function before there's any transformations or changes occurring. Okay. And that graph we want to be very familiar with. We studied a lot in Algebra 2. Is the parabola at the origin, right? So then domain, range, intercepts, symmetry, continuity, and behavior, and increasing or decreasing are the different characteristics we want to be able to describe from the graph, of the parent function, and part of it we could be using the graph to think about it, right? Is the domain, so far we've seen the domain as negative infinity to infinity. Is that still going to be the case here? What would you say, yes or no?
It should still be negative.
Yep, it is still negative infinity to infinity because all values can be plugged into x, or we can see that that U shape is going to keep getting wider and wider and cover all x's. Both ways to think about it. Yep. And then range. So far we've seen the range as just the constant, negative infinity to infinity, right? But if we're looking at this graph, its lowest y value is 0, right? And then it goes up to infinity. So our range now is 0 to infinity. So domain is pretty similar in a lot of the cases. Range is where we're going to see the most change.
Okay, ninth grade, last names beginning with D. Please head down to the new auditorium entrance. Ninth graders, last name beginning with D.
Sorry. So x-intercept and y-intercept, again, from a parent function, commonly it's going to be our origin 0, 0. right? So symmetry this time, if we were to reflect it across the y-axis, would it be the same? Or if we were to take a point and rotate it 180 degrees, would we land on the graph still? So is it, or if we took the whole graph and rotated 180 degrees, would we get the same graph? So is it symmetric about the y-axis or is it symmetric about the origin? What would you say? So you can drop it in the chat or unmute and share us what you think. Share with us what you think. What are your thoughts? If you flipped this graph across, this is not a perfect graph, but if you flipped the graph across the y-axis, would it get the same graph? Or if you rotated 180 degrees around the origin, would it get the same graph? What are your guys' thoughts? So yes, this is symmetric about the y-axis because if we were to flip it across the y-axis, it would get the same exact graph. So symmetric about y-axis. Okay, continuity, right? If we put our pencil down for right now, that's our definition of continuity. If we put our pencil down when we have to lift it up to draw the rest of the graph, we would say, yes, it is continuous for all x's. Okay, and behavior. Oops, I crammed myself. I got excited. I can still make it fit. As, well, that's going to bug me. Why did I switch colors? As x goes to negative infinity, where does our graph go this time? So as x goes to, sorry, I said negative infinity, I didn't write it. As x goes to negative infinity, where would you describe the y values going towards? That is our end behavior. Thank you. Yep. So as x is going to negative infinity, the y values are going to positive infinity, or we can just say infinity. Same question or same idea. As x goes to infinity, where's the function going towards? Positive infinity. Thank you. Okay. And then so far, last question is increasing and decreasing. So in our first case, it was neither increasing or decreasing because it was constant. In our second case, it was the line that was only increasing, right? In this case, we see as we read it left to right, we see decreasing. So because it goes down and then it goes back up, right? So we'd say decreasing, and we just say what x values it is decreasing for. So from negative infinity, so as x was from negative infinity to 0, we need to put a parenthesis though because that is a turning point. So it's neither increasing or decreasing. So from negative infinity to 0, and then it increases from the 0 to infinity. So parentheses 0 to infinity. Okay. So that's a little bit newer, especially thinking about that definition, increasing, decreasing, and keeping in mind those turning points. That's where a common mistake for students is they put square brackets, but that is a maximum or minimum point. So it is the highest point, lowest point, or also known as a turning point in direction. Okay. So then fourth, parent function. So all of these so far should feel very much review, very familiar functions. Okay. So cubic is f of x equals x cubed. Any ideas, or how would you think to describe the graph? Since this is a review function, how do you think of a graph of a cubic? How would you describe it? I like that description, like the quadratic, but the other side. So it goes up similar to the quadratic, but the other side is flipped down. Did you guys ever do like the function dances? This would be like that Disco Man. Maybe not. Maybe I'm just being silly. And that's totally fine. Domain. So we want to think about domain, range, intercepts, symmetry, continuity, and behavior. I can make it fit on one. I'll make myself. Increasing, decreasing. Is the domain in this case still negative infinity to infinity? Just like we've had so far? Yes. Yep. So negative infinity to infinity. Or the domain is, you can say in set builder notation, the set of all real numbers, set of x, such that's all real numbers. Range. So last time it had a minimum. So we saw the range stopping at 0 and going to infinity, or starting at 0 and going to infinity. In this case, because of that flipped quadratic, right? I like that idea. We see that it goes all the way down and all the way up. So same idea, negative infinity to infinity. Intercept, because it's a parent function, both x and y. So some of with parent functions, a lot of their characteristics are very similar, but we still want to be practicing thinking about them. So both in x, y, and intercept is at the origin. Symmetry, so this has not been the same every time. Symmetry, if we flipped it over the y-axis, so if we took the whole graph and flipped it over the y-axis, would we get the same graph? So is it symmetric about the y-axis? That's a yes or no. What do you guys think? Nope, it would not get the same graph. But if we were to take the graph and rotate it 180 degrees, or if we picked points and rotated them 180 degrees, would we still land on our graph? So are we symmetric about the origin? What do you think there? Yep. Yes, I got yes in the chat. So yes, symmetric about the origin. Yes. Oops. Our answer is just symmetric about the origin. Okay, and then is it continuous? So far, yes, all of our parent functions so far, they're not going to be the case for always, but is yes. Yes, it is continuous for all x values. If you were to pick a spot and start drawing, you would not have to pick up your pencil. Okay, and behavior, as x goes to negative infinity, where does our function? And this, keep in mind, f of x could be replaced with y. You can see both answers in this case. So as x goes to infinity, where does y go to? Or where does f of x go to? So either drop it in the chat or unmute. What would you say your answer is there? hmm The function goes down, so it's going to negative infinity. And as x goes to infinity, where does the function go? How do you describe that in behavior? Sorry if I overspoke someone. So we would go to infinity. And then in this case, so last time we had decreasing and then increasing. This time, if we're reading from left to right, would we describe it as decreasing or increasing? Yep. So we would see it is increasing the whole time because it's going up. It does slow down in how fast it's increasing and then speed back up. So that's more of like a calculus idea is how is it increasing? But for us right now, we just want to say it is increasing the whole time. So from negative infinity to infinity. Okay. So the next function we're going to start off with, so we're going to leave here, but the next function we're going to start off with so you can start thinking about is square root function. So you can get a head start with what would you describe, how would you sketch that graph? And how would you describe all of its characteristics? So